Hi friends, today let's look at an interesting problem called rotting oranges. In this problem, you are given an m cross n grid where each cell can have only one of three values. 0 represents empty cell, 1 represents a fresh orange, and 2 represents a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. What is asked in this problem is we have to return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. Let's look at this example. Here we are given a 3 cross 3 grid with 7 oranges, out of which one is rotten, and the coordinate of the rotten orange is 0, 0. So 0th row and 0th column. Every minute, the neighboring oranges of this particular rotten orange will also get rotten, which means in the minute one, right one and the bottom one, both of this will be rotten. In the next minute, newly rotten oranges neighbors will get rotten. If you look at this, the right of this orange will also get rotten, and the bottom of this orange, which is this one, will also get rotten. And if we consider this particular orange, so the right of it is also bottom of this. So yeah, anyways, it's got rotten. We consider all the neighbors of the freshly rotten orange in each iteration. You're getting the pattern, right? If we continue in the minute 3, all the neighbors of the existing rotten oranges will also get rotten. In this particular case, only this particular orange will be rotten. And in the next iteration, the last one will also be rotten. So it takes 4 minutes to rot all the oranges. So the answer is 4. There are two other conditions. What if there is a fresh orange which is not adjacent or neighbor of any other orange? In that case, we have to return -1 because it will be impossible to get that orange rotten. And the other case is when there is no fresh orange. All the oranges are rotten in the grid. So here we are given with that example as well. So let's say this is a grid with a single row, and in that row there are just two cells, and one of the cell is empty and the other cell is a rotten orange. In this case, since there is no fresh orange that can rot, so the answer will be 0. Now let's look at how we can approach the solution. If you see, in every iteration we consider all the neighbors of the existing rotten oranges. For example, in the minute 0 there was just one rotten orange. We considered both its neighbors, and since both its neighbors were fresh oranges, we marked them as rotten. So we got into the state that is shown in minute 1. In the next iteration, we then look at the freshly rotten oranges and then go to their neighboring cells and see if cells have a fresh orange. If they are fresh oranges, we mark them as rotten again and we move on. So this is breadth first traversal. If you want to know more about breadth first traversal, I have added the link in the video. So looking at the solution, first step is we initialize a queue by using Python list data structure, and we also initialize fresh count to 0. So fresh count, this variable will be used to count the number of fresh oranges initially in the grid, and later on in the end, if the fresh count doesn't become 0 again, then that means all the oranges were not rotten, and in that case we have to return -1. So this will be used for that. So fresh count will be used to calculate whether all the oranges were rotten or not. Number of rows and number of columns, this will be used to iterate through the grid. We also store the result in this particular variable result, and we have initialized it to 0, which signifies minute 0. We iterate through the grid and we insert all the coordinates of rotten oranges in the grid, and along with those coordinates we also insert 0, which means minute 0. So that signifies the time. In the same loop, we also count the fresh oranges in the grid. Now we start the loop of breadth first traversal where we iterate through the queue, and this runs while queue is not empty. In every iteration, we pop from the queue and calculate the result. So result will be max of existing result and the new time that we get out of the queue. see if that is greater than the existing result. If yes, then we reset the result. So that's what is done here. Next, we look at all the neighbors of this particular rotten orange of coordinate I comma j. To do that, we use this for loop where dr and dc signifies the delta row and delta column, and we add this to I and j. So dr and dc will be 0 minus 1 0 1 minus 1 0 or 1 0. R will be I plus dr and c will be j plus dc. So r and c are coordinates of neighbor. There will be 4 neighbors. Next, we see if the coordinate r comma c is valid or not. If r and c are valid coordinates, then we also see if that particular coordinate has a fresh orange. If that is the case, we mark that particular orange as rotten, and we append this particular like coordinate r comma c to the queue for the next iteration. The time is incremented by 1 because now we are marking the neighbor as rotten. The neighbor was still fresh, so that's the reason it's prev time plus 1. At this point, we also decrement the count of fresh oranges. Fresh count minus equals to 1 does that. In the end, we simply return the result if fresh count is 0. So this means all the oranges were rotten in the end. So result is the valid number of minutes that it took to rot all the oranges. Otherwise, we return minus 1, which is the case of impossible. Time complexity of this particular solution is O of n, where n is number of rows multiplied by number of columns, and space complexity is O of n, again because we use a queue data structure, which is a collection that can basically consist of all the elements in the grid. If all the elements are, for example, rotten oranges, in that case queue will initially consist of all the elements in the grid, so it will be O of n. Thanks for watching. See you in the next video.